Welcome back. Today we're going to talk about the functional group ethers, and there's a little bit of nomenclature we're going to revisit, but there's also plenty of synthesis to talk about. So let's start with the nomenclature. Okay, so to remind you, an ether is a molecule that contains a carbon, oxygen, carbon functionality, and the carbon groups right here are not carbonyls, they're just regular, aromatic, aliphatic, alkene, alkane, even alkyne type of carbons, but not carbonyl compounds. And the way you basically go about naming these compounds is to basically name the alkyls that you have. If they happen to be the same type of alkyl on both ends, then you just call this dialkyl ether. So if this is pentane, a pentyl group, and that's a pentyl group, then this will be dipentyl ether. Another way to name them, if you have different groups, is to pretty much just name one alkyl followed by the second alkyl, and this will be alphabetical, and ending with the word ether. And this is the common name of naming your ethers. So if you look at a molecule like the one right here, you have an isopropyl group on one side and an ethyl group on the other. So you will call this ethyl isopropyl ether, once again alphabetically order, right? So ethyl before isopropyl. But you could also call it by the proper IUPAC name. That would be 2-ethoxypropane. And in this case, the parent chain is a propane. That's the longest chain. So this is actually an ethoxy group that's bound to it. Okay, as a second example, here we have a sec-butyl functionality bound to the oxygen, but we also have cyclohexyl. So then this will be called sec-butyl cyclohexyl ether. And to remind you about the rules of nomenclature, the prefix sec does not count for alphabetical purposes. So it's actually the B that you would account for in terms of alphabetical priorities. And so B comes before C. And that's the reason why you have sec-butyl appearing first. So sec-butyl cyclohexyl ether. You could also, in this case, the parent chain will be the cyclohexane. You could also call this sec-butoxy cyclohexane. And here, this is one of the more used ether materials out there. This is known as diethyl ether. So you have two ethyl chains bound to the oxygen, and diethyl ether, that's normally how you would call this molecule. The IUPAC name will just have to be ethane being the parent chain and ethoxy being bound to it. So this will be ethoxy ethane, but diethyl ether is the most used and common way of referring to this molecule. Okay, and then you could also have more complex molecules like the one I'm presenting down here. And what you can see here is once more you have that sec-butyl functionality bound to the oxygen. Over here you have a cyclobutane structure bound to it, but this cyclobutane contains substituents of its own. So in terms of naming it, you will have the sec-butyl appearing first, alphabetically speaking, and then after that you have the cyclobutyl. But the cyclobutyl contains two methyl groups sticking out of it at positions 2 and 3, hence the numbers right here, 2 and 3 dimethyl cyclobutyl, and all of that has to be in parentheses because that entire thing is a substituent. In front of it, you have the number 1 telling you that the oxygen is bound at position 1 in the cyclobutane or cyclobutyl substituent. And of course, don't forget to write ether at the end of the name. Alternatively, if you want to go with the IUPAC name, you could call this 1-sec-butoxy. So now this whole thing is a substituent, and the parent chain is your cyclobutane structure. So sec-butoxy is one of the substituents. You still have the two methyls, so it's 1-sec-butoxy, 2,3-dimethyl cyclobutane. So two ways of addressing the same type of molecule. Sometimes it might be easier just to stick to the IUPAC name, like in the case of these complex molecules. Other times, if you're dealing with simple alkyls, then you can just use the common name, the ether name for naming these compounds. Now, in addition to the regular acyclic ethers, we also do have some. In fact, we've encountered a few already in prior lectures that happen to be cyclic. And this one right here, you may recall, this is your epoxide ring. This is also known as oxacyclopropane because you are forming the cyclopropane type of structure, but one of the carbons of the cyclopropane is now replaced with an oxygen. So we describe that situation by using the prefix oxa. All right, so oxa stands for oxygen, oxacyclopropane. And over here we have a cyclobutane type of ring, but one of the carbons is replaced by an oxygen. So we will call this oxacyclobutane. It is also known by its common name of oxetane, much like oxacyclopropane is known by its common name epoxide. All right, then you have here another situation, two oxygens on the cyclobutane type of structure. So here, because you have two oxygens, you have to dictate the quantity using prefixes for the oxa portion of the name. So this will be dioxacyclobutane, but now you have to be even more specific. You have to tell where those oxygens are located. The first one is at position 1, and the other one happens to be at 2, 3, position 3 of the cyclobutane ring. So this is known as 1,3 dioxacyclobutane. Down here, there's another molecule that it's often used in organic chemistry for reactions, as well as just to have a solvent in which to run the reactions. All right, so what you will notice right here is that you have a cyclopentane type of structure, but you have two alkenes. So this is actually cyclopentadiene. And one of the carbons of the cyclopentadiene structure is an oxygen. So we also have to include the oxa. So this will be one oxa. The first alkene appears at position 2. The second one appears at position 4. So notice that in the name we have one oxa cyclopenta 2,4-diene for the IUPAC name. The common name, however, which is the most preferred way of naming it, is known as furan. And so, technically you can call them both, of by either one of the names. Furan is the preferred way of calling it because it's a lot simpler, as you can tell. And there's one variation of this one, the fully hydrogenated version of furan, which technically means that you have 4 extra hydrogens, is known as 1-oxacyclopentane, right? So here you don't have any more alkenes, so you just name it the way we've named the other type of ether cyclic compounds, 1-oxacyclopentane. But if you look at it from the point of view of the common name and what we had right here, we have added 4 extra hydrogens to come up with the fully saturated version. So this is known as tetrahydrofuran. Tetrahydro implying that you have 4 more hydrogens than furan did have. And also, we abbreviate tetrahydrofuran as THF, and this is by far one of the most used solvents in organic chemistry. I certainly have used it in the past to carry plenty of reactions. The only somewhat bad thing about it is that it does have somewhat of a funky smell. It's not the most pleasant molecule to to be exposed to, I suppose. All right, now, and another one that's also useful is this one right here. This should be called by the traditional name 1,4 dioxacyclohexane, right? And that will be the proper IUPAC name. But it's also known as 1,4 dioxane, and some people just call it dioxane, period. It gets used pretty often in organic synthesis. Okay, the last point that I want to make is that if you recall from our lecture, probably our second lecture, um, the boiling points of ethers are actually, and surprisingly, rather low. In fact, unless the ether is pretty small in size, meaning that it only has about 4 carbon equivalents present in the molecule, the boiling points of ethers tend to be actually lower than even alkanes, alkynes, and alkenes. And for sure, by the time you go past 6 carbons or 6 carbon equivalents in your ether, you end up having boiling points that are pretty low. In some cases, they happen to be the lowest in the series. And this is because you are diluting away the polarity of the carbon-oxygen bond by increasing the length of the aliphatic, aromatic, hydrocarbon functionalities of the molecule. Okay, so with that being said, we've addressed the nomenclature of ethers. In the next set of videos, we're going to talk about the synthesis of ethers, and there's a couple, well, actually a few methods to do this. So let's save that for the next video. I'll see you then.